In this video, we're going to discuss function decomposition, which means decomposing our solution to a problem into multiple function designs, where each function accomplishes a subtask of the original problem. When we're designing programs, we want our programs to be readable so that others can read and understand them, and so that we can read and understand them when we come back to work on them in the future. We want them to be maintainable. Programs need to be updated over time to add new features or to fix errors. And readable code is much easier to maintain. And if the code is easy to read and update, it's less likely that programmers will introduce bugs when they change the program. We've been focusing on writing readable, maintainable code during the entire course. Our systematic and standardized design process guides us to write code that is readable and consistent. Our style guidelines, for example, our use of upper camel case for type names and lowercase for variables, further guide us to write readable, consistent, maintainable code. In this module, we'll learn about how to decompose or break down functions so that each function is accomplishing exactly one task, and together they accomplish our original goal. We'll learn how to break down big problems into smaller problems, each of which you can solve using the design process we've already learned. As an aside, remember that the design recipes are already helping you break problems into smaller pieces. A function design or data definition design is broken down into multiple steps so that you can focus on one thing at a time. We've already seen one example of breaking down a problem into multiple functions. In the last module, we saw that a reference to a user-defined type in a data type definition leads to a call to a helper function in the template. In this module, we are going to look at further examples of when and how we can decompose a function into multiple functions. This decomposition makes our function designs easier. It doesn't mean it will be easy, but it is easier to design each helper function and only have to think about that subtask in the function design than it would be if we had to try to keep the entire problem space in our head at once. We will introduce rules to help you decide whether you need to create a helper function. But remember that the overarching goal is one task per function, or that each function accomplishes exactly one task. The helper rules are meant to guide your thinking and help provide examples of cases in which we should break a function into two or more functions. We will review the reference rule and learn about two new rules, knowledge domain shift and composition. However, if you're ever unsure about whether a rule applies or which rule might apply, take a step back and consider the overarching one task per function rule. That is our goal.